Truly incomprehensible are the voids that occupies the space between the visible matter in the universe. Some voids, appropriately called super voids, can be millions of light years across. Take the Boötis void, for example. It's 250 million light years of almost nothingness. From this image, it might not look that bad until you realize that almost all of the galaxies shown in the circle lie in front or behind it. To date, only 60 galaxies has been found within this void. A space that large could easily contain 10,000 galaxies when compared to other regions. Just imagine if an alien civilization like our own exists on a planet within one of these galaxies. The nearest neighbor would be tens of millions of light years away. Even worse, if your planet is orbiting an intergalactic star, it's a star or star system that has been ejected from its home galaxy and is now floating freely through the cosmos. Magnetars is a form of extremely magnetic neutron stars. From around 400 kilometers, the magnetic field would strip you of all metallic objects such as your phone, watch, belt, glasses, and so on. And if you got really close, it would eventually start ripping out the iron in your red blood cells out of your body. There's a weird correlation between the distance and size of the sun and our moon, because during a solar eclipse the moon almost perfectly covers the sun, but there's really no physical reason why this has to be the case. The moon just happens to be 400 times smaller than the sun, but the sun just happens to be 400 times further from the Earth than the moon is. Another object we can see with the naked eye is the Andromeda galaxy, and it looks a little something like this. But because Andromeda is so far away, we only see the very bright center of it. If we could see all of Andromeda, our skies could look like this every night. It would be several times larger than the moon, even though it's 2.5 million light years away. Right now, no matter if you're moving or sitting still, in a universe where everything is orbiting, spinning or pulling, you're moving at incredible speeds. Electron spins around the nucleus of atoms, and we humans, being made of atoms, rotate along with the Earth. The moon orbits the Earth, the Terran system rotates around the sun, and the Sol system rotates around the black hole in the center of the Milky Way galaxy. Several smaller galaxies part of the Milky Way subgroup orbits the Milky Way. The Milky Way subgroup rotates around the gravitational center located somewhere between the Milky Way and Andromeda, which is all part of a collection of larger galaxies called the local group. And our local group of galaxies orbits along other groups of galaxies within the Virgo supercluster. And this supercluster is along with countless other superclusters being pulled towards a much larger supercluster called the Great Attractor. And in turn, the Great Attractor is pulled towards the largest known supercluster in the local universe, named the Shapley Supercluster. The days on Venus is longer than a Venusian year. Venusian. That sounds so sci-fi for some reason. Venusian. Basically, Venus completes an entire orbit around the Sun in a little more than 224 Earth days, but take 243 days to rotate around its own axis only once. Thus, its days are longer than its years. We all know that sound cannot travel in a vacuum, and that space is a vacuum, sound waves cannot travel through it. Pretty basic stuff. I even talked about this in previous episodes. However, something that surprised me when researching for this episode is that this isn't exactly true, because space is not the total vacuum it's often made out to be. Space contains lots of particles and atoms and gases which sound can use as a medium to actually travel through. But of course these particles are very sparsely spread out, so you need an extremely sensitive microphone to be able to hear anything at all. And NASA did just that. They used a very sensitive microphone of sorts and aimed it at a galaxy with a black hole at its center. And the sound it produced is the lowest note in the universe, 57 octaves below middle C. The frequency is more than 1,000,000 billion times deeper than the limits of the human ear. Back in 1962, during the Cold War, the US decided to blow up a hydrogen bomb in space. Not only that, it was 1,000 times more powerful than the bomb that hit Hiroshima during World War II. What's so crazy about it is that they did it because they simply wanted to see what happened. An equally insane plan was something called Project A119. The project had a goal of detonating a nuclear bomb on the moon. Fortunately, this never actually took place. Ever watched a sci-fi show such as Star Trek and wondered how they navigate? I mean, how do they know where to go when space is mostly nothing? Because you can't use a GPS in space, right? Well, scientists have been working on something called XNav. The way it works is by detecting signals from pulsars in a similar way to how a GPS sends and receives signals from satellites. Pulsars are dense, rapidly rotating stars sweeping their emissions across the cosmos at rates that are so stable they rival the performance of atomic clocks. This timing property is perfect for stellar navigation and would have an accuracy of between 5 to 10 kilometers. That's the equivalent of having a GPS here on Earth having an accuracy of a few nanometers. However, the technology to create such a device is not quite here yet, but we will almost certainly see it in the near future.
Turn right in 5 million light years.
You may or may not have heard about something called dark matter. Basically, when scientists use the word dark to explain something, it's some really complicated stuff. But I'm gonna try and explain it anyway. Think of our solar system. Our sun, all the planets and everything else that we can see has mass. The more mass an object has, the stronger gravitational force it has. Okay, we know this stuff. We can accurately calculate the correlation between mass and gravity. Now take the mass of the entire Milky Way galaxy. Take everything we can see and put all that mass together. But here's the problem. The amount of gravitational force that the galaxy has is not consistent with the amount of mass it has. We have done these calculations over and over again, accounting for all the stars, dust and gas, everything, but it never seems to add up. What does this mean? This means that there is something we cannot see affecting the gravity around us. And here is where dark matter comes into play. A good analogy could be wind, for example. If you're inside a house looking out the window, you can't see, feel or hear the wind outside. But if you look at that flag, you can see that it's somehow moving. Thus, you can prove that something you cannot see must be affecting it. And that's a very simplified version of what dark matter is. The most recent calculations shows that as much as 84.5% of the total matter in the universe could be dark matter. A common argument you hear people use against space exploration is that we still have huge problems down here on Earth and that we should focus on solving these issues first before we even start thinking about venturing out into space. And while it is true that we as a species have yet to solve numerous major global problems with our society and the planet itself, space exploration does actually help you down here on Earth more than you might think. For example, when NASA tried to find ways to minimize the size of the cameras on their spacecrafts, it led to the invention of the first active pixel sensor. It's the reason we can all do this with our phones today. In the 1980s, NASA developed a unique polyimide material which could be used to make flexible circuits. How would that benefit me, you'll say? Well, today almost every electronic consumer product like mobile phones, digital cameras, TVs, computers, etc. is made possible because of this. NASA's robotic research has greatly contributed to both the appearance and functionality of artificial limbs. Scratch-resistant glass was invented for the visor on astronauts' helmets. Many of the athletic shoes you can buy today were inspired by the spacesuits from the Apollo missions. Today you can find space blankets in almost every first aid kit. Infrared ear thermometers measures your body temperature the same way NASA measures the temperature of stars. They have developed water purification systems which can yield safe, drinkable water from some of the most challenging sources such as urine, sweat and even mud. These systems are helping people without fresh water around the world right now. The point is, not that we must go to space to find these technologies. The point is that because we went to space, we did.